Strange Loop, hello. I just want to say thank you for sharing the Saturday post-lunchtime together. This is my first Strange Loop, and I'm so grateful to be here. The organizers, people, and conversations have been just amazing. Thank you. I'm super excited today to share patterns and stories on how you might improve your operational tooling around CI with traces. Worked with and found the same general patterns apply when building operational tooling for scientists, traders, crisis responders, and of course, where I spend my time today, software developers. Real quick, I want to share two of my favorite talks from yesterday. Richard from Stripe talked about generating code with simple transformations to make code more usable. Melinda from Eggy talked about message queues with architecture trade-offs to make your platform more resilient and legible. These talks presented something you're already doing, like CI, with a small wrinkle to make the system better. I want to share my curiosity in exploring the space and help you get excited and intrigued enough to explore your own distributed systems in a similar way with traces. I'm going to leave some takeaways and tools and references to get started. A URL will be in each slide. And the Slack channel is also right over there. It's pretty long. But if you're open to it, just raise your hand and ask questions during the talk, and we could have a conversation. We could probably explore something pretty interesting together. And we're going to talk about one of the hardest challenges in distributed systems today. What is your code in production doing? How is it doing that? And why is it doing that? The patterns we're going to explore on improving your CI tooling are going to be building a common language for infra, clients, and people. How to reason about complex issues with humans in your tooling. And finally, how to use context to understand what changed. I'm Frank, by the way. My pronouns are he, him. I've been at Slack for about 2 years and guided many of our internal teams on how to instrument and improve observability with traces to solve problems. One particular problem we'll explore in depth is test flakiness on Slack's monolith. It came down by magnitude over the last years. Of course, as with many complex problems, there's never one single cause nor solution for flakiness, as it has many inputs from software and people. It's a socio-technical problem that takes time to understand and effort to start solving. For engineers, flakiness is extremely frustrating, and for service owners, hard to concretely pinpoint. By the end of this talk, you'll have the patterns that we use to solve multiple layers of flakiness in CI. First, how many of you have been on call? Wow, yep. Let's say you're on call and things are not fine. You're trying to find a needle in a haystack of your deployed code and infra. To do so in the old world, you can add some logs or metrics. Needle, so to speak. And to be able to find those needles in the haystack, you need to redeploy your haystack and wait for that data to show up. What happens instead of inserting log lines and metrics into your code? You could teach your tracing platform to answer those questions about your haystack. Hey, historically, what does hay look like? And what doesn't look like hay? If you look at code traces over time with context, you're able to see what might have changed. Both changes and non-hay might be indications of where needles, and therefore problems, lie. I'd like you to listen for iterations of that haystack analogy throughout the rest of this talk. This hierarchy of needs describes a model that I use internally to inform how observability drives understanding of performance and resiliency bottlenecks. This learning helps us make bets on more observability changes or changes in workflows to help people do what they really want to do. And again, we use observability to inform solving problems in this space. And the agenda is generally, we're going to talk a little bit about our department and some challenges and sources of challenges in CI. We're going to hear a little bit about how we got started and how we implemented our first cross-service trace, what we learned along the adoption journey, and finally, where we are today. So first, I'd love to spend a few minutes talking about developer productivity and business goals. Developer productivity is about building tools and programs used to get Slack software to customers quickly and with high quality. It's been a fun journey to be on as Slack scales. I work with teams that have the opportunity to make engineering at Slack simpler, more pleasant, and more productive. Both Slack customer and code bases grew quickly over the last 6 years. And this begs the question, how might we create better internal tools for engineers to build, test, and observe deployed code? Well, there are challenges. As the great philosopher Uncle Ben from Spider-Man once said, with great power comes great responsibility. In the same way that it is exciting, there's a shadow side to great growth in customer and code bases. There's an increase in complexity, oftentimes with fuzzy service and team boundaries. Here's a simplified architecture diagram of Slack for desktop and mobile clients going through multiple backends. Slack evolved from a single web app to a topology of many languages, services, and clients that serve different needs. The core business logic lives in web app and routes to other services like a distributed cache called Flannel, a distributed MySQL service called Vitesse, search and discovery, and many others. Oftentimes, internal tools were built quickly and scaled just enough for Slack's main monorepo, web app. In 2019, when I joined, our team was already growing and at about 6 folk. Today, internal tools teams consist of 60 people. And hopefully this challenge resonates with y'all. Services are reasoned about individually within team silos, typically using logs and metrics. For example, the Vitesse team might create a Prometheus metric for errors with different dimensions that are meaningful for development. Another team might see this and create a circuit breaker for error rate, but misunderstand the nuance and then misuse this metric at the course level without context. And finally, user experiences in CI is somewhat unique when compared to traditional distributed tracing use cases for things like APIs. CI workflows might span over days or even weeks. They go through developer environments, commits, and different asynchronous parts of the infrastructure. So given this, how might we do better? In my previous role, I helped build products and teams to help companies with the hardest problems by reasoning about data, pipelines, and platforms. I found you can create massive business results when people speak the same language and reason about data using that language. Oftentimes, one team's definition of dimension X might mean something completely different between teams and especially business groups. So let's take a different approach. How might we create a common infrastructure and language to increase legibility and unpack complexity across teams? How might we create an integrated diagnosis and reasoning about complex system interactions with people in Slack? How might we evolve our observability culture? How can we share this tooling with teams that need it? And so this body of work was a slow conspiracy sprinted on between many teams and didn't happen overnight. I want to say a special thank you to Suman and Ryan on the observability team who founded that thesis around SlackTrace, and to all the folk who improved the CI ecosystem with traces. But first, how do we come to this approach? It is slow is the hardest problem to debug in distributed systems. It is flaky is the most heard problem by internal tooling teams. A tracing system doesn't tell me what's slow or flaky, and more importantly, why. It's an exercise oftentimes left to the reader. An in-depth exploration of SlackTrace is written by my mentor and colleague Suman and can be found in the blog post linked. For the purposes of this talk, I'll share a sky-high view of the motivation and this infrastructure. First, we start with the span event structure such that we can create an event once and then use it in multiple places. For example, a function within web app might create a single span event. This deep span event will contain context for the rest of the user request with both upstream and downstream context. We can now ingest these spans from separate clients and are able to craft views from the same data model by processing it through Kafka. Users can access spans through a data warehouse through using Presto SQL queries and real-time stores like Honeycomb and Elasticsearch. Here's a simplified view of our CI workflows for users and infrastructure. I'll use web app and end-to-end tests for the purposes of illustration. Web app is where most engineers at Slack spend most of their development time. It ties together business logic from each client and dependent services. The CI workflow probably looks familiar. A user pushes a local branch to GitHub, opens a PR, then presented with test results. The screenshots show DMs from Checkpoint, an internal CI/CD platform. It drives and bridges user workflows between GitHub Enterprise, AWS services like S3 and Kubernetes, Jenkins, Consul, and QA environments, which are really beefy machines running Slack to execute end-to-end tests. You might be asking, what might go wrong? Good question. When I joined in 2019, a lot of existing CI logic was written by the CTO and early employees. It was mostly untouched for 4 years. It mostly worked just well enough. Well, why trace? To find causation. Today, there's many more downstream services from web app. And the cardinality for CI traces are very different from other services like web app. CI has lower volume, so there's no need for sampling, but higher criticality. CI requests go through critical interconnected systems, and a fault in any system typically means users are blocked. So what does a fault look like? Engineers hit retry on their tests and are frustrated when anything in that hot critical path fails. Between 2017 and 2020, Slack saw a 10% month-over-month growth in test execution count, so multiple doublings. Many new services came up to support various features in Slack, and this led to a lot of systems being stretched to their absolute limit. And so there's a lot of needles in the CI haystack. The user experience was bad for a while. Before a series of projects around GitHub load, circuit breaking on dependencies, anomaly detection, and workflow changes, we were seeing a PR flake rate at approximately 50%. That's pretty bad. This macro percent PR flake rate metric you could think of as bubbling up multiple commits and potentially hundreds of test suites that run on every PR. And for developers, this really breaks trust in tests and slows down velocity. Observability through tracing played a role in each of these projects. And today, we're at approximately 5% flake rate per PR, like about 10x better at the macro metric. Both velocity and confidence have increased in recent developer surveys, and unlike previous years, flakiness wasn't a top issue. And every day, we're still learning how to understand, operate, and evolve this very complex system called Slack. Many business requirements, services, and teams are constantly changing, especially compared to when most of our CI infrastructure was first built. Early on in my time here, I saw an opportunity to work with the observability team to build a better set of tools to understand and to change how we looked at CI. Let me share how we got there. I looked at my early Slack history and found my first conversation with Suman in mid-2019. This was a time when we still went to the office on a daily basis, and we'd grab hipster coffee with colleagues. I heard about Suman's exploration and building of SlackTrace, and I understood a similar problem in data platforms very well and reached out for a coffee together. I then spent an afternoon to build a cheap prototype with a hypothesis that this type of tooling would become a critical and compounding value add for developers. An easy place to prototype was our test runner, affectionately called CI-bot. Even during this PR and a couple of simulated test runs, I noticed Git checkout was slow for a portion of our fleet. We had our first tracing win that afternoon. It turns out a few instances in the ASG were not being updated, which was an easy fix once we identified the needles in our haystack. Before I move on, I needed to write code to make this happen. I want to call out that today we have a rich ecosystem of tooling that didn't exist or were much more premature when we started this work. During this year's Strange Loop workshop, Steve Flanders shared how to get started on OpenTelemetry, and I heard it was great. Also, if you have the chance, stay around for the next talk by Jessica from Honeycomb in the same room. If you visit the resources section in the link, you'll find links to Honeycomb's reference on OpenTelemetry collectors and a sample Go test collector from Rakel from AWS. this is a few months later now. This is a juicy incident. This is day 2 of a multi-day, multi-team incident full of cascading failures. On day 1, we were scrambling with one-off hacks to try and understand what was happening and get a few overloaded systems under control. On the morning of day 2, I added a simple cross-service trace and reused the same instrumentation from our test runner. Very quickly, with Honeycomb's bubble-up functionality, it became very clear where the problems were coming from. Git LFS issues popped up on a third of the QA environment fleet, and this was slowing down the entire system. The discovery was a simple query knot tracing platform on what doesn't look like everything else. And within 2 hours, CI pipelines were flowing again, and engineers could do their work. Over the next few months, this led to the first of many targeted investments for CI tracing. Here's a sample of the shared dimensions we created for users and developers in CI to make queries in Honeycomb legible and more accessible. These dimensions were stubbed early in our library and instrumented with a few clients. Since then, various teams have extended and reused these dimensions for their use cases. And this graphic shows a very, very high-level zoom out for individual traces and what dimensions they might use in CI. In a single trace, example, tests, it might capture all the data shown in the rightmost column. You could then track earlier related traces for all those shared dimensions elsewhere. You could query to find like commit-related test and build traces to see if we're seeing build failures or other test failures due to a code issue on master. Let's go back to the root challenge. Developer frustration across Slack was increasing due to flaky test runs over the last several years. Flaky test runs was one of the top reported issues in developer surveys for a few quarters already into 2020. By mid-2020, automation teams across Slack had a daily 30-minute triage session to triage and focus on the flakiest tests. Automation team leads hesitated to introduce any additional variants on how we use Cypress, an end-to-end testing framework. The belief was that test flakiness was from the test code itself. Yet, there wasn't great progress. I typically work on the infra side of the world and felt strongly we could do better with causation on gray failures by instrumenting how we use the Cypress framework. Gray failures are where the system itself reports as healthy, yet the application, in this case, tests and the test platform, report a failure or flake. After some negotiating and identifying no verifiable decrease in performance and resiliency, we scoped a short experiment. We'd instrument the high-level test platform runtime for a month and capture some variables. What could go wrong? Well, a lot went right. We discovered a few runtime variables correlated very, very strongly with the higher flake rates. In this graph, you can see compute hours spent on just flaky tests. At peak, we were running roughly 90 hours of very large, very expensive machines on tests that were discarded because the results were flaky. And to build confidence and address concerns, at every merge and hypothesis test, we queued up revert PR at the same time. We never reverted. So the other challenge I mentioned earlier is like fuzzy service boundaries, especially came to how services operated for internal use, like dev or QA. A broken dependent service like search or an upgrade in a vendor's checkout library API might mean that tests will start to flake for users in CI. While a full discussion of anomaly detection and circuit breakers is beyond the scope of this talk, I hope to share a few screenshots of how we were able to build the glue for service and automation teams to have discussions in Slack with links to more detailed observability. Oh, and before I forget, in the coming week, I'll be posting to the Slack engineering blog on how we produced a magnitude of change in CI spend with a deeper look at circuit breakers as one of those big changes. But what we found was that by detecting and bringing people together in a single conversation, we could triage a lot better by looking at the same things. And just like in summary, it's like test suite owners may not be distributed systems experts, and service teams may not be aware of how internal customers use their services. In conjunction, these missing pieces presented a working space for disjoint teams to find causes for CI flakiness and give an awareness when a test suite or a dependent service was failing. And so let me share a quick story about another recent incident in August 2021. At Slack, we use the incident command system, and I'm sharing one of the conditions, actions, and needs, abbreviated CAN, messages from that incident. The condition screenshot from our incident channel says it best. Backend unit and integration test suites are failing at a high rate with out-of-memory conditions on hosts. Each of these backend unit test suites may run tens of thousands of tests. The day before our incident spun up, we actually saw memory tip over the threshold and cause our anomaly detection to start noticing a higher flake rate, kind of like the straw that broke the camel's back. During the incident, we used test case traces from backend tests implemented earlier to track down high memory footprint jumps for test cases. We were able to see a high increase at the P50, P95, and P99 down to the hour over the last few months. And subject matter experts were able to identify a few culprit experimental PRs that may have been the cause for those jumps. And during the incident, there's always this holding pattern after someone makes a change. Here's some screenshots from the long thread. And I'm just going to talk through some of the juicier parts. Folks ask questions like, did it work? What did the graphs show? And during this incident, this was top of mind for all of us. And so testing changes are always hard. Error 1, how do we test this change? Responders with identities and names blurred for privacy were able to revert the PR from a few months earlier, and within minutes, tests appear to be passing at a higher rate. Error 2. Another responder was able to reuse an earlier query looking at memory usage for test cases in Honeycomb. Error 3. So this data allowed us to look at telemetry with context. The changes and breaks became apparent when we took this type of approach. So in summary, we significantly reduced CI customers' flake rates and irritation using a few tools, mostly centered around distributed tracing. This also helped us change the curve of CI when compared to baseline growth. This socio-technical change was super fun to play with in the last few years. And I hope to hear from you specifically about how you solve these type of challenges in your company. Thank you all very much. And I'd love to open the floor for questions.